Today, I'm going to share with you guys 5 of the best Python habits that you can start using today. This is going to allow you to create meaningful, readable, and reusable code in no time. Welcome back, guys, to the channel. Welcome back, guys, for another episode of Code with Josh. For obvious reasons, I'm Josh, and I'm happy to have you guys here. Do me a favor before I dive into the video, help me out and hit that like button and subscribe. That really does help me a growing channel, and it really does help me reach more people within the YouTube algorithm. Crazy world. I mentioned today we're going to cover some of the 5 best Python habits that you can implement today in no time at all. And this is going to take your coding skills up a level, making it more readable, more reusable, and more modular in no time. Guys, the first link in the description is my weekly Python newsletter that you guys can come on, check out, and I write weekly breaking down these topics into more bite-sized chunks that you can follow along with. And all the other links in the description, well, they're dedicated to you. Wherever you're at on your Python journey, they're there for you. So check those out below. Enough said, let's get into why you're here. What are the best Python habits and how can you start using them now? Okay, so you can see I'm here in a module that I've created, mymodule.py, and I've made a function. This function, when I call this, is just going to make a random list of numbers, and it's going to print my list of random numbers. I can run this code, and let's check our output. And you can see it outputs it really nicely, exactly how I want it at the bottom. Now, this is a module, so I want to use this module in other parts of my code. So if I head into my main Python file, let's start off by importing our module. From my module, import random list. Now I should have access to that. So in my main function, in my main Python file, I could call the function that I have stored here. When I run my code, we should see the output we want. Oh, but oh no, what happened, right? We called it, it printed 2 times. Now this is where if name in main comes into play. In my module, the reason is when we import a module, Python is going to read that module script from top to bottom before using it in our main Python file. So common syntax at the bottom is we say if name is equal to main, and I can store my function inside there. What this means is this function, this code is only going to be called if I run this module directly. I would have to run it right here to call this function. In my main code now, because I'm running my main Python file, not the module, when I run this, you can see that it outputted exactly what we want, and I'm now using the module how it's intended to be used. Right? Because I'm not running my module, I'm running the main. So by using our boilerplate, if name equals main, this only runs the code if I'm in the module. But for standard practice, if I'm down here, I should be having this boilerplate down here as well. If name is equal to main, and this is going to run the exact same way, and this is why we commonly see at the bottom of your Python scripts, if name is equal to main. Run it to double check, and you can see the output as it's intended to be. If I asked you to make a variable for number, what would you do? Well, most of us would probably say number equals 25 or variable equals 25. But this is where type annotations or hintings come into play. As a developer, you should be documenting your code the best of your ability, right? So you're going to thank yourself later, but other people will thank you as well, right? Writing good, clean, readable code. Now, an annotation is not necessary, but it helps create more readable code. So I could have a variable number, and I could put a colon and say that's going to be an int. Right? Because imagine if someone else gets access to your code and they said number equals 25. Well, these are different types of data in Python. One is a float, one is an integer. You don't want someone to accidentally change your code that could then break your program. So for example, let's create another one. Let's say price. Price is never an integer. Price is a float. So I could say price is a float, 23.75, right? I'm now creating more readable variables with type annotations. Let's take this up a notch. Let's, for example, create a list of passengers. So what type of data is this? It is a list. Okay, I could leave it at that, but then I could go a step further. What type of data is in your list? A string, right? So now I can make a list and I could say Bob, Josh, Sally, right? This is a list of strings. Here it's going to be a list of type of strings. The same thing works for a dictionary. If I made a dictionary of students, right, it's going to be a dictionary. That's great. What is the key in your dictionary going to be? Well, I could say the key is going to be a string. What is the value? Well, that's up to you. In this case, I could say the value is going to be an integer. Now, when I make my dictionary and I say Bob, and let's say Bob has an age of 35, okay, this matches my type annotation, right? It's so much more easier to read here. And actually, I have two equal signs. Let's replace that with my colon. This makes it so much more clear and readable. Okay, students is something. What is it? Oh, it's a dictionary with a key of a string and an int as the value, right? And we can even take this a step further when you're making functions. Let me just make a function called like find even ages. Okay, and if I make it like normally, right, this could take a list of ages and I'm going to find the evens in that and I want to append them to a different list. So for age in ages, if age modulo 2 is equal to 0, that tells you it's an even number. We could just append that age like so. When the function's done, of course, I'm going to return my evens list because that's the function's job. But really, I want to document this. I want to use a type annotation. So I could say here now, imagine ages is, let's make this a bit more challenging, is a list of strings. So now I know the function is going to get a list of strings. Okay, and well, it's going to output, I can use an arrow here, a list of integers. When I read this function now, it becomes so much more clearer, and I know how it's going to work. I know that it takes a list of strings. I know it's going to output a list of integers. If I ran this, I'm going to get an error, right? Because if I give it a list of strings, I can't do any of these logical operators on that. Right, so I could just, there's a few different ways. I could sneak this in here, and we're just going to append int age instead. Okay, so that's how we can use type annotations or type hintings to document your code. This is a best habit in Python.
Hey, real quick, guys, if you're getting value from today's video, do me a favor and help me out. Hit that like button and subscribe. That really does help my video out in the YouTube algorithm and reach more people around the world.
Next up in best habits is we have comprehensions. Now, typically this can be done with lists or dictionaries is where we're most commonly going to see it. And this should look very familiar because coming from type annotations, I use this as an example. I have a list of scores and I want to find all the even numbers. Now this code is going to work if I print it. I'll run my code to demonstrate that. And a comprehension is really compacting all of this into a single line of code. So I could do the same thing in one single line. So for example, if I come down here, I'll keep everything as we have it. I'll actually come right here instead. Okay, and let's create a list called evens. And I could start by making a list. Now, what is each element in my new list going to be? Well, each element is going to be a score, all right? Where am I going to get that score? How do I get it? I'm going to create my loop here for score in scores. So everything here is just being compacted. Score is going to represent each element in your list. 2, 33, 45, 88, etc. Where am I getting the score from? Well, I'm going to loop through the original list scores. So currently, this is just the same list. But now we could apply a condition. I could say if that score, modulo 2, is equal to 0, when that condition is met, it's going to be put in this list. So everything I have here is now irrelevant. I've done that in a single line of code. This is our list comprehension. When I run this, our output is going to be the exact same. It's done faster and more optimized, making this a best habit in Python. There we go. Okay. Now I did mention a dictionary as well. Let's say I have a dictionary of scores, and really I want to see if everyone passed or failed the class. So for example, let's say anyone higher than a 60 passes and anyone lower than a 60 fails. So I ultimately want to create a new dictionary. Josh, pass. Chuck, pass. Annie, fail. Right? If I were to write normal Python code, I could say results, right? And I want to now loop through my dictionary. So for what? For, let's say, student and score in scores.items, that unlocks our dictionary for us. If my dictionary, so if scores, what is the key? The key is going to be represented by each student. So if the student score, if their value is over 60, then I want to basically create a new item in my new list. So results, the key is still student, and I'm going to say pass. Else, if we come down here and I can say results, student, otherwise they fail. That's really what's happening here. If I print off, I could say results, and let's give our dictionary into play here, and I run my code, we will see a new dictionary outputted with either pass or fail for each student. There we go. Josh passed, Chuck passed, Charlie passed, everyone passes, except you can see here Annie failed. Now, you could do this, right? But you can see that it takes 1, 2, 3, 4, 5, 6 lines of code when we could achieve the same thing through a comprehension. So I'm just going to build on results now. Okay, so I'll take it. I'll keep everything we have for you guys so you can read as I go through here. But let's say I want to make a new list of results. Okay, that's great. Now, what is each item in the dictionary? What is the key of each item? Well, the key is going to be student. Okay, and then what do I want the value to be? Well, I want it to be pass if the score is greater than or equal to, we can say 60. Else, I want it to be a fail, right? So that is the value right there, right? My key is student, just like here in items. And then the value is a conditional statement. It's going to be pass if this is true, otherwise we fail. Okay, what am I going through? Well, just like before, for student and score in scores.items, just like so. All of this now is irrelevant. Okay, we've achieved the same thing in a single line of code. When I run this, our dictionary comprehension is going to output us those same results that we're looking for. Boom, there we go, right? Another best habit of Python. Now onto our next hack. I like to create a main function in all my Python scripts. And you can really think of this main function as the controller to your script. Because when I run a script, I really just want to be calling one function, which then calls other parts of my code and then acts as a controller for it. Now, I kind of want to use everything, all these best habits that I've been sharing with you guys here in a single program. I've covered if name is equal to main and type annotations. And the two functions that we have here, we've worked with these previously. Let's begin before I even create the controller, the main function. How could you use type annotations to increase the readability of your code? Right? Because these functions aren't very well documented. Numbers, what is numbers? Numbers is a list. You could leave it at that, but numbers is a list of integers. Great. What is it going to output? Well, it's going to output a list of even numbers. So it's also going to output that list of integers. There we're using our type annotations. Pretty cool. On the second one, this is going to take a dictionary. Now the key to the dictionary is a string and the value is an int. What is this going to output? Well, this is going to output another dictionary where the key is a string and the value is a string. Guys, if you're getting value, do me a favor, hit that like button. And if you're not already subscribed, subscribe to the channel. We've now used type annotations, right? Now I want to create what we call a controller function. Well, I call it that, right? It's really just the main function, but it's one function that I can call that controls our program. You've probably seen this in other Python files. So I'm going to create a function called main. The output is none for this. And inside here, I can really just call parts of my program. So like function 1, function 2. Remember to give it any arguments it needs. So scores, and we have numbers. Because I am returning the results here, okay, just for this here, I'm going to print this off, right? But our main function, right, we don't necessarily need to print if we want to use that code on the outside. Now we have a main function completed. When I run this code, well, one, nothing's going to happen yet, but I want main to be called, and then main is responsible for calling function 1 and 2. Let's use the first best habit we talked about. If name is equal to main, right? So I need to be inside this script here. And when I run the script directly, that is what this syntax means, it's going to call main. And then main will do the job of calling other parts of our program. So when I run our code now, our controller function is being called here. And there we have the output that we're looking for. Pretty amazing. This brings me to my final best habit for Python. And this is really dealing with unexpected behaviors with mutable default arguments. So here is just an outright basic function. Okay, it's add item. It's going to take an item. And then I want to give the user the option to either pass their own list or use a default one if they don't provide a list. So most people are going to create the item as the parameter and then give a default one here. So items equals a list. But this can lead to some really unexpected behaviors, right? So I could obviously do this. This is going to be the output. All right, but the unexpected behaviors are now coming into play when we do this. This is a bad practice. Don't do this. Because every time you call this function, it's going to change this list here, right? And because ultimately every time you call it, it's creating a new empty list. And we don't want that. To prevent this, what we want to do is we want to pass in none as the argument for the list. And this will initialize the list inside the function instead of here as the parameter. And what we're going to do during the setup this time is we're just going to say if items is none. So if we don't give a list, fair enough, I'm then going to create the list inside the function. None is going to check if we don't give a list, and it's only going to initialize a new list if we don't give it to begin with, right? I need to give it a list of my own. If I don't, then I've given it none, so I'm going to create a new list. This approach is so much better because it ensures the unintended sharing of a list across different function calls. So the next time you're dealing with mutable default arguments, list, dictionaries, don't just put in there your square brackets. No, change that, create that, right? Because you should be thinking ahead. What could the user do wrong? What could break your program? By saying none, I then check if items is none. If it is, I can take a step to ensure that something happens, right? So always ask yourself, if you're giving a list as an argument, right, should you be making this as none? Because every time you call the function, you don't want your code to reset. This is a much better practice in Python.
Well, there you have it, guys. Those are the 5 best Python habits that I can share with you guys here today. Now, I want you guys to practice implementing these techniques. So open up your latest Python project, right? We love projects. That's the way I learn. That's the way that I teach my students project-based learning. Take one of your projects, spend an hour, right, and go through the project and try and implement some of the habits that I taught here today. As you start creating new projects, remember these habits, keep them in your mind so you can start creating more readable, reusable code in the real world. Guys, if you got value from today's video, help me out. Hit that like button. And if you're not already subscribed, I have weekly content coming out to help you guys grow. So what are you doing? Hit that subscribe button, Python crew. Well, until next week's episode, I will see you then.